So today we're going to be looking at how do we actually graph the gradient function. So to begin off with, let's just have a think about what the gradient is. Well, this is the instantaneous rate of change. I like to imagine it like it's a surfboard, and this is the tangent line. This blue line here is the tangent line of the red point. And as the red point moves along its line, you can see that the surfboard is sometimes pointing up, sometimes it's flat, and sometimes it's negative. So we can say that that's a positive rate of change, this is a zero rate of change, and this is a negative rate of change. 0, positive, 0, negative. And so depending on where we are on the line, sometimes it's going to be steeper, so that's a really positive, this would be really negative, or not that steep at all. You can see around here it's only just a little bit positive. So the tangent line can tell us the sign or the gradient of the function. So whether it is pointing up, down, or flat. Let's apply this then to a situation where we've got a graph. So in this case, we've got a simple line. And we can think about what is the slope of this line? Well, it's a negative, right? Because it's pointing down to the right. But we can actually calculate it exactly using the gradient formula. Alrighty, so that means if I was going to draw the matching function, matching graph for this one here, it'll look something like this. X is going to be along here, and instead of y, we're going to have the gradient. We want to compare the slope to the x coordinate. And then we can just draw in our gradient line, which is going to be of the form y equals -3. And there it is, our function. Let's have a look at a more complicated version. Now for something like this, we can imagine, once again, that we are on the surfboard. So here, it's a negative surfboard. As it gets here, it's a little bit less negative. And at here, it is a 0. Then it begins to start increasing. Okay, so this is a parabola, and you can see that it is going to be negative, negative, 0, and then positive. Okay. So let's think about that in terms of a table. So at this section here, it's going to have a negative. At this exact point here, it's going to be 0. And then after this point, it's going to be positive. So we can almost split the graph in there in two. Now we can record this in a particular table. So at the beginning, the shape is down. Then when we hit that x equals 2, then we get it that it is a flat line, and then it is increasing again. So you can see that these three shapes kind of make up that smiley face as well. And so this has a negative sign, this has a 0, and this has a positive sign. So for the graph that we're going to draw for this one, we need something that starts out negative, gets to 0, and then grows positively. And it's going to look something like that. And you can see that this is matching where the graph is. This dotted line here matches this dotted line here, because that's exactly where the slope becomes 0. Let's look at a slightly more complicated one. So this one is negative, then it is flat, then it is positive, then it is flat, then it is negative, and then it is still negative, and then it is flat, and then it is positive. Okay, so quite a lot of changes on this one. Let's draw up a table. So it starts off negative, then flat, then positive, then flat, then negative, then flat, and then positive. So for each of these, we're going to put in a different sign. This is a negative, that's 0, that is positive, that is 0, that is negative, that is 0, and that is positive. Alrighty, so there's our table complete, and now we've just got to match that on our gradient graph. Let's draw up the axis. So let's start off by putting in all of our 0 points. So that first one here happens at -6, the next one here happens at -2, the next one here happens at around 5. So let's put those zeros in on our gradient graph. So -6 is here, -2, and 5. And then we just need to know which way is it behaving before that. Well, it's negative before, and then it's positive, and then it's back to 0, so it turns around, and then it goes to being negative, and then it stays negative all the way until it hits 5, where it hits 0 again, and then it begins to be positive again. And there is our gradient graph. So we're just following. Whenever it's negative, the graph is in the negative, and whenever it's positive, the graph should be in the positive. Let's look at the last one. Alrighty, so this one's quite an interesting one. We start off with a slightly negative one, and then it gets more and more and more negative, and then it's negative, and then it becomes slightly more positive. But you can see that the entire graph has a negative gradient. But there's this interesting thing that happens. So it's a negative slope before and it's a negative slope after, but in the middle we have an asymptote, and the asymptote needs to be respected. So let's draw up our table. So it's negative, then there's an asymptote, and then there's negative again. So negative asymptote, and then it's going to be negative. So for this graph, it's going to be negative, and then it is going to be negative again, except there's going to be an asymptote in the middle. This is how it's going to look. Now, if these were straight lines, we could see that it would just be negative the whole way through. But it's actually not. You can actually see that the gradient changes. Up here it's almost 0, but by the time we're here, it's getting really, really quite steep. These lines are getting steeper and steeper, and then here we're getting the reverse. It's quite steep, but then it slowly shallows out. So they're going to be approaching 0 here and approaching 0 on this side as well. So let's draw that in. So the asymptote is maintained, and we have two graphs that stay negative but are approaching 0. So it's going to look something like this. Now on this side you might think it might also be up the top. However, it's negative the whole time. So it's going to look something like this. And that is the slope of the gradient. Alrighty, there you go. All done.